All right, this video is just to describe three of the parent functions and different parts of them. That way you have them just in case you ever want to look at them or for a refresher. First, we're going to talk about a quadratic equation, and we're just going to kind of go through these steps, I guess. So many of you have seen this before in Algebra 2 classes here at Liberty, and it's really pretty awesome. So if you see the word quadratic, my hope is that already you have this U shape in your head. Like you're like, oh, it's quadratic, and you see that parabola. And so we're going to just kind of build from there. So we can choose some X values and get some Y values. And I generally like to choose things that that are like that: -2, -1, 0, 1, and 2. 0 is awesome. It's like the best one to choose. So let's substitute that in. -2 squared is +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So if we go over here and we plot this, we are going to have a picture of a parabola. And this is a really poorly drawn example of a parabola and the parent function. So let's talk about domain. Remember, domain are the X values and range are the Y values. The way that I do this is like this. I kind of look at it. Remember, domain is looking this way. So I go across the bottom and I'm like, where do I first see my graph? So I'm looking, and hey, I first see it right here. And the first thing I see is an arrow. So we're going to keep going, keep seeing it, keep seeing it, keep seeing it, and there is an arrow. That's the domain. So when you have an arrow, that represents that it's going forever. So if the arrow is on the left, it's infinity. If the arrow is on the or negative infinity, if it's on the right, it's infinity. So the domain, and you could write this a couple ways, is -infinity to infinity. Or you could also write x is between -infinity and infinity. Those are two different ways that you can write the domain. For the range, we're going to do that same process, but looking up from the bottom. So I'm looking, where do I see it? Where do I see it? Oh, here it is. And it starts with a point. And then I'm going to keep drawing until I don't see it anymore. And the last thing I see is an arrow. So this point is at 0 on the y-axis, and this arrow is going up, so that's infinity. So our range will be from 0 to infinity. The bracket, because we're including 0, there's an actual point there. Or again, you could write it 0 is less than or equal to x is less than infinity. X is between 0 and infinity. All right, I hope this is ringing a bell. X-intercept, so the zeros. Where does this graph cross the x-axis? Well, it only crosses the x-axis at 0, 0. So the x-intercept is 0, 0. The y-intercept is where it crosses the y-axis. And again, on this one, it's still 0, 0. End behavior. What happens at each end? So as x is going to -infinity, as it's going this way, what is happening to y? So as x is going this way, this graph is going up with an arrow. So y is approaching infinity. As x is approaching positive infinity, y is again approaching infinity. It's going up. Asymptotes are where the denominator is equal to 0, and we don't have a denominator, so there are no asymptotes. A turning point is where it changes from going up to down or down to up. So our maximum, where's our highest? Well, we don't have one. Okay, but we do have a minimum right here at 0, 0. That's where it changes from going down to going up. And I know that's kind of confusing because I just said it's going up when it goes this direction. But for this kind of thing, you're going to be looking left to right. Now, as far as increasing and decreasing, that's what this little graph is for. So this is the x-axis, all right? And we're just going to look and draw a little picture of what's happening. So as we see this graph, it's first coming in and going downhill, and then it's going back up as x gets bigger. So the increasing interval, it's getting bigger from 0 to infinity. And it's getting smaller from negative infinity to 0. That's where it changes. And at no point is it flat. So there's no constant interval. So this is the graph of a quadratic function. And I'm going to go ahead and do cubic next. All right, so now we have a cubic function. Cubic being y equals x cubed. So if we give ourselves some points, -2, -1, 0, 1, 2, those are just great ones to use, then we're going to substitute in. You should, upon seeing this, be able to remember that a cubic function looks like that. So just kind of keep that in your head. -2 to the third power is -8. -2 times -2 times -2. -1 to the third power is -1, 0, 1, and 8. So you can see in a cubic function, this is rising and falling much more rapidly than in a quadratic. And also we have negative values here that we didn't have before. So let's go ahead and plot our points. -2, -8, -1, 1, 0, 1, 1, and 2, 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's try to draw this guy. And we know it's going to keep on going. It's not just the points that we picked. So there's our parent function of a cubic function. So let's go ahead and do domain and range again. So looking from the left to the right, where do I first see my picture? I first see it right here with an arrow, continuing until about right there with an arrow. Arrow pointing this way is negative infinity, and that way is positive infinity. So we can write it in interval notation or in set notation. X is between negative infinity and infinity. For our range, we're going to be looking up. So we first see it right here at the bottom, and we keep seeing it, keep seeing it, keep seeing it, all the way to here. Pointing down is negative infinity, pointing up is positive infinity. So our range this time is negative infinity all the way to infinity, and it is y is between negative infinity and infinity. And all of a sudden, I think I put x in the middle on the quadratic one. That should be a y. The x-intercept, where does this cross the x-axis? Well, here's our x-axis, and I only see it right here. So 0, 0 is our x-intercept. Our y-intercept, or where it crosses the y-axis, again, is at 0, 0. And behavior. As x is going this way, what is happening to y? It's going down. So as x approaches negative infinity, y is approaching negative infinity. And as x is going up, y is going up to infinity. Again, there are no asymptotes because there are asymptotes are where the denominator is equal to 0 and we have no denominator. Turning points. So our little guy is going up and it's getting bigger and bigger and bigger, and then it changes. But it's actually still going up. So from here, everywhere we look, it's going up. It's not changing direction, but it's changing a little bit, but not direction. There's no max and there's no min. Now here's our x-axis. Let's look. So from this way, if we're looking at it, it's going up to 0. And from 0, it's still going up. So it's increasing the entire time. It's never changing. It's going from negative infinity to infinity. And it's never decreasing. It's always going up. And there's no constant part, so that's it. All right, so that's the overview of a cubic function. And let's look now at a rational, reciprocal, or inverse function, all the same. All right, let's graph some points. We're going to have -2, 1, 0, 1, 2. Now, when you think of rational, you should think of this kind of a picture. So if we substitute in -2, then we're going to have -1/2, 1 and 1, 0 and undefined. There is no point here because 1 over 0 doesn't exist. All right, now we're back to, that should be -1, 1 and 1/2. Now this isn't quite enough to get a good picture of it, but we're going to draw it based on this. So our first point is -2 and -1/2, -1 and -1. And if you kept going, it would really look like this. Never touching 0 because it doesn't exist. 1 and 1, 2 and 1/2. It's going to go just like that. So that's what the parent function of that one looks like. What's the domain? Well, coming from the left, we see it starting here, and we keep seeing it, and we keep seeing it, and we keep seeing it until right here. And this is getting closer and closer to the axis, but it's not actually going to hit it. Okay. Then it picks back up right on the other side, and it keeps going forever. So this is infinity and -infinity. But here at 0, there's like a hole because it doesn't actually go there. So we can see this from -infinity all the way to 0, but not including 0. And from 0 all the way to infinity, but not including infinity. Or but not including that 0, I mean. So that's why it has a parenthesis. So that's one way to write that. For range, we see it starting here at the bottom, and it's going all the way until here there's a hole, and all the way to infinity. So we have the same situation. It goes from -infinity to 0, but doesn't include 0, and from 0 all the way to +infinity, domain and range. The x-intercepts, there aren't any. This doesn't cross the x-axis in its parent function, but it will cross the x-axis when you add or subtract something from the y, okay, from here. So if we add -2, we're now going to have some spots where it crosses the x-axis. Again, same for the y-intercept, none in the parent function, but if we add or subtract something from the x, then it is going to cross the y-axis. End behavior. As x approaches -infinity, this graph is approaching -infinity. As x approaches +infinity, the graph is approaching +infinity. And this time there are asymptotes because there's asymptotes when the denominator equals 0. So to find them, 1 over x, 1 over 0. So there is an asymptote at, I messed that part up. You're just going to take the denominator and set it equal to 0. So there's a horizontal asymptote at x equals 0. And for y, it is also at 0. And that's because if we rearrange this problem by cross multiplying, we would get 1 equals xy, get the x alone, the y, yes, the x alone gets 1 over y equals 0. So there's an asymptote at y equals 0. That part's a little weird, but it's just to find the asymptote, you set a denominator equal to 0. All right, turning point. So as this one is coming over, it's getting bigger, or smaller really, this whole way, and then it keeps getting smaller. It's getting smaller, and it keeps getting smaller. So there is no maximum and no minimum. Next, this graph is getting smaller here, and then it kind of picks up and gets smaller again. So at no point is this really increasing. This part, you know what? I'm gonna have to redo this part of the video because I need to check on this because my brain just stopped working for a second. But I will check on that. And there are no constant intervals. And I'll come back and replace this part because now I just confused myself. And that's okay, that happens. So I will come back and fix that part of the video in a little while. All right, hopefully this was a good refresher. Goodbye.